So I'm going to type a question now, and there is a very important questions covering very important methods. How many words can be formed by the letters of the word daughter? Taking, now we are talking about the methods. Taking all letters together or beginning with D, and we have also to talk about beginning with D and ending with R. And we also to talk about that how many words can be formed using the letters of word D when vowels are being always together. All vowels do not occur together. So this question has 5 parts. It's an amazing question to understand uh, the concept. Okay. So this is the question. Now let's start solving it. So what do we have? The word daughter. Daughter. So there is no letter which is getting repeated. For checking any if there is any letter which is getting repeated or not, we'll start from the left and look at all the letters that are right words to the word that we are looking at. So D, is there any other D? No. Is there any other A? No. Is there any other U? No. Z? No. H? No. T? No. E? No. R? No. No repetitions are there. Okay, cool. So in the first case, we have to take all the letters together. Okay. So we are free to use them in any manner to so basically we'll have to use all the letters. How many letters are there? Four and four and four. So 8 letters, 8 places. So how many letters do we have? 8. How many letters do we have to arrange? All the letters. And we have to first select 8 letters from 8. Okay, that is very easy selection. And thereafter we have to arrange them. So 8p8, we can also write it as 8p8, or we can understand that we are arranging n things on n places. So n factorial basically at 8 factorial should be our answer, which is 40,320. Is the first part clear, everyone? That we have to just arrange all the letters of this word, and we have to find out that how many words we can form after arranging them, or after interarranging all the letters of the word daughter. Any questions? No? So let's move ahead. The B part. In this particular case of set of words, we have to make all the letters which are starting with D. Okay. So if a word is going to start from D, then the first place is very fixed to us. We write D here. And let's copy it. So the first place is fixed that D is going to use. How many choices for the first place? 1. Okay, now we are left with 7 words with 7 places to be arranged. So basically 7 words to be arranged and select first 7 words to be selected from 7. Okay, thereafter we will have to arrange them on 7 places. 7p7, nice. So 1 into 7p7, or we can also write 7 factorial. 7p7 is 7 factorial only. Is that clear, everyone? How it is happening? The 1 into anything becomes itself only. NPR for formula is n factorial upon n minus r factorial. 7 minus 7, 0 factorial, which is 1. So it has become 7 factorial only, which is 5040. So there are 5040 ways to arrange and make a word from by using the letters of the word daughter when the words are starting from D. Is that clear, everyone?
Yes, sir.
Okay, great. Let's move forward and let's take the question with us. The next slide. Now we are done with A and B part. Now let's discuss about the C part, where we have to make a word which is beginning with D and ending with R. So out of 8 letters, we have used the 2. Now we are left with 6 places to be filled with 6 words. So 6p6 or 6 factorial basically. How many choices for the first letter? Only one choice. How many choices for the last place? Only one choice. So 1 into 6 factorial into 1 into 6 factorial into 1 is 6 factorial, which is 720. Is this part clear, everyone? C part?
Yes, sir.
Yes. If you are like confusing, then first and second place, first and last place has only one choice of filling it with D. Let's now discuss the D part, where we have to bring all the vowels out of daughter together. So in daughter word, please tell me all the vowels. A, U, and then E. There are only 3 vowels and 5 consonants. Okay, now we are going to use a certain method that is known as box method. Okay, in this condition which is given to us, we have to bring certain letters together. So we will do one thing. We will take a box, and whichever elements that we have to keep together, we'll place them inside. Which are, so there are three letters that we have to bring together. So there are 3 places inside the box. Now, how many letters do we have? 3. How many places? 3. Okay. 3 choices for the first place, 2 choices for this, 1 choice for this. So basically, 3 factorial are the number of ways in which A, U, E can get arranged. 3 factorial means 6 ways. So it can be E, U, A, or something, like 6 times like this. Okay. So A, U, E, these 3 letters will be arranged on 3 places inside the box in 6 ways, in 3 factorial ways. So now in this particular box, all the vowels are going to remain together. Now we have to arrange this box with the remaining consonants. How many consonants are there? 5 consonants are there. Okay. So there are 5 consonants, and we have to originally we have to we had to originally fill the 8 places for daughter word, right? But out of 3, in the place of 3, we have now brought a box on the place of 3. Okay, so instead of 3, there will be a single place because the box is having 3 elements inside. So now how many places do we have in total? Say 5 for the consonants, 1 place for the box, right? So 5 for the consonant, 1, 2, 3, 4, 5, 1 place for the box. Okay. So now how many total elements are there that we have to arrange? 5 consonants plus 1 box. Okay, so five consonants plus one box is six elements in total. How many places do we have? One, two, three, four, five, six. Six places, six elements. How many total method are going to be there? There are six factorial ways to arrange them. Okay. Now there was also arrangement inside arrangement inside the box. So they are independent events. So we are going to use the fundamental principle of counting, and we are going to multiply the number of ways of both the events. 6 factorial into 3 factorial will be our total number of ways in which we can form a word by using the letters of word daughter when all the vowels will be together. So our answer will become for this particular part 3 factorial for interarranging the box and 6 factorial. Is that clear, everyone? Or should I repeat? This is important for you to understand. I will also repeat if you have any doubt.
Yes, sir. You can repeat, sir.
Okay. So let's go to the next page. Let's bring our question as well. See, we have to make a word of 8 letters. 3 and 3, 6. These are 8 letters. So 8 places need to be arranged with the letters of a word having 8 letters. Great. Now, in this particular condition, it is mentioned that all the vowels of the word has to be remain always together. Means the vowels are A, U, and E. These are 3 vowels in the given word. Now, it is mentioned that when we will be making these words, so we cannot do this, that any vowel is not together. Now, A is not together with U and E. Okay. It has to be like this. Sorry. R. Okay. It can be like this. Have I missed any consonant? G, Z. Okay. It has to be like this where A, U, E is always together. Is always together. You may bring it to the end of the letter or here, doesn't matter. But A, U, E in any order has to be together. All the vowels should be together. It can be also UAE, doesn't matter, but vowels has to be together. That is what question is asking from us. Is that clear that what are we supposed to do? Is that clear that what is our aim to find out in the question? Okay, let me repeat then. We are required to make all the words, okay, using the letters of this word daughter. Now, there is a condition given to us in the D part where we have to write all the vowels while making words. We have to write all the vowels together. Okay, means A, E, U, all these letters will always remain together. There cannot be any consonant in between. There cannot be any consonant in between, and they can be written in any format like E, A, U. That is also togetherness of vowels. That doesn't matter for us. So what we will do, our method to solve this question is, we will pack all these vowels inside a box, and we'll take the box of the size of the number of elements that we have to arrange. Here we have to keep 3 letters together. So there will be 3 places inside the box. Now 3 places, 3 elements to be arranged. How many ways to arrange these elements inside the box? 3 factorial. Because 3 choices for the first place, 2 choices for the second, 1 choices for the last place. That is how 6 in 6 number of ways these 3 letters can be arranged on 3. So that's a box where it is going to keep all the vowels together inside the box. Okay, fine. Now, what else we are supposed to do? We have to arrange this box inside in the with the letters, with the remaining letters that are consonants. How many consonants are there? D, G, H, T, R. There are 5 consonants. Okay, so there are 5 consonants plus we have a box of vowels. We have a box of vowels and we have 5 consonants. Now we have 6 elements. To arrange and make a word. Okay, so what will happen that if there are 6 elements, there will be 6 places, and for the first place, how many choices are there? 1, 2, 3, 4, 5 or 6? 6 choices. For the second place, there will be 5 choices because we cannot repeat. 4 choices for the third, 3 choices for the fourth, sorry, 2 choices for the fifth, and 1 choice for the last place. They are dependent event, so we'll multiply them. So there are 6 factorial number of ways to arrange these 6 elements. And in this particular element, which is a box, to arrange elements inside the box, we were having 3 factorial ways. So this event of arranging 3 vowels inside the box, it will also be counted. So 3 factorial multiplied with 6 factorial. Now the event of arranging 3 elements inside the box and arranging 5 consonants and a box, basically 6 elements on 6 places, they are both dependent event. So total number of ways in which a word can be formed by using the letters of word daughter, where all the vowels will always remain together, is this are these the number of cases. So if we want to further solve, 3 factorial is 6 and 6 factorial is 720. 6 2 is 12, 1 carry, 4320 is the answer. Is there any doubt? If there is any, please ask. I'll repeat it. Let me explain it. Let me explain the working also. Let's use the next page. It is reluctant to. So basically, after arranging all the vowels, what letters of the word were left was the consonants. Okay. So now we will be interarranging consonants and these 5 consonants. So let me just give you some illustrations so that you will be able to better understand. So what will be happening that it may happen that the box come first and then there are some consonants in any order, or it may happen that there is a consonant, then there is a box of vowels, then there are other consonants. It may also happen that the box of the vowels is in the second last or third last place. It may happen anything. So basically now we are treating the box as as equal as, same as other elements. So how many elements are there? 1, 2, 3, 4, 5, 6. 6 elements are needed to be arranged, 6 factorial. In that particular one element, that has also some inside things that were also arranged. So in that box, there were 3 places for 3 vowels, and 3 vowels were to be arranged in 3 factorial number of ways. How? Let me. There were 3 elements A, E, U. So you could have written A first, E, U then. That's one way. A, U, E. Or another way is writing U, A, E or U, E, A. U, please work. U, U, A, E and U, E, A. Let me save the file. U, E, E. Now this time starting with E, A, U, E, U, A. So these many arrangements can be made with 3 words on 3 places. So 1, 2, 3, 4, 5 and 6. So these are the 6 number of ways in which 3 letters can be arranged inside the box. And similarly, the 1, 2, 3, 4, 5, 6, these 6 elements can also get arranged. So we will multiply both of the events because they are dependent events to make our word. When only one happens, then only then the second can happen. So they are dependent. That's why we are multiplying, not adding. Now, is that clear, everyone? Any doubts? So we have solved this, 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 this. If there is any doubt, please ask. I'll not proceed till you respond. Unless you respond.
No, sir.
Okay, so is my voice audible?
Yes, sir.
Okay. So let's solve the last part, the question. That all vowels do not occur together. In this case, we have to tell that when there will be please copy. Here. So we have to now tell the how many words that can be formed by the letters of the word daughter when all vowels do not occur together. So in this particular case, how you can solve it? You have to find 2 things in here. First, calculate total number of arrangements that can be made, total number of words that can be found basically without any condition. Word that can be formed minus the opposite of the condition that is given. So what is the opposite of the condition that is given, that when there should not be any vowel coming together? That is all vowels being always together. So that's the opposite condition. If we subtract from the total number of cases from the opposite condition, then we will have the answer. That is there, what we need to find out. Is that clear, everyone? How we have written so that all vowels, when they will not occur together, then we can just find out the total number of words that can be formed in any without any condition, subtracting it from the old vowels when they were coming together, because we have already found out these two. This we have find it out in A, and this we have find it out just now in D. Okay, but still we have eight letters, eight places to be arranged, no conditions, simply 8 factorial minus all vowels being together, always being together. So how many vowels? Three vowels. So 3 factorial for the box, plus how many are remaining? 5 consonants and the box. So 5 plus 1, that is 6 factorial. So 3 factorial into 6 factorial is the number of cases where all vowels will be together. Now let's solve them. 8 factorial is 8 factorial is 40 320 minus 3 factorial was 6 into 720, which was 40,320 minus 4,320. Okay, so 0, 3232, 40 minus 4, that is 36. Okay, is I'm correct? No, 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 no. 0 minus 0, 0, 2 minus 2, 0, 3 minus 3, 0, 40 minus 4, 36. So 36,000 are the number of cases. That's the correct answer. Is that clear, everyone?
Yes,
This single question is really very important for you to understand the concepts. Most of the concepts have been covered in this question. There's one more good question. This time we'll discuss about the ring ceremony. In how many ways can 6 different rings be worn as on the 4 fingers? Now, 4 fingers of a hand. Simple question. So we are discussing the case of Papillary or Bapillary. I'm sorry. May his soul rests in peace. Bad example. Anyways, we're talking about a person who wears lots of rings, and he has uh, unfortunately only 4 fingers on his hand. Okay, so he's going to use 4 fingers only, not the thumb. So we have to now tell that how many ways, in how many different ways he can wear those 6 different rings. Okay, so how many places that are needed to be filled? First finger, second finger, third finger, fourth finger. How many choices for the first finger? 6 choices. How many choices for the second? 5 choices. 4 choices. 3 choices. But there is a mistake here. We have now, after using all the fingers, all the rings, 2 rings will be still left. Because in this condition, what we are assuming that we will be only wearing one ring on a finger. So that's not what we are supposed to do, so because we have to utilize all the rings. So instead of considering our fingers as places, we will consider these rings as our places. Why? Because rings are fixed here. They are fixed event. Every ring is going to get on some finger, that is for sure. Okay, and we write places and we refer to the places. When we write places now, We refer to the places only when that particular place is definitely going to get filled. So the finger was not sure, but we are very sure with the ring that we are not going to waste it. Okay, so ring number 1, ring number 2, ring number 3, ring number 4, 5, 6. How many choices for ring number 1? There are 4 choices. 4 fingers are available. For the second, there are also 4 fingers because we may have multiple rings on a single finger. Same goes for the third, fourth ring, fifth ring, and sixth ring. Ring 1, ring 2, ring 3, ring 4, ring 5, ring 6. Dependent events, so it will get multiplied. 4 raised to power 6. 4 is getting multiplied 6 times here. Okay. Now, this particular case gives us a formula that number of fixed events or elements, I should say, raised to power number of chosen events or elements. Or should I say non-fixed, because they are chosen. Okay, so this is one more formula finding the total number of cases. There are a lot of examples for the same question. Let's take one. Is this question clear? Any doubts? Why we have taken 6 rings as the places? Because every ring has to get on some finger, that is for sure. That's why it is a fixed event, and hence we have considered it as a place. Is there any doubt? Please ask.
No, sir.
Move ahead then. There is a question. In how many ways can 6 apples be distributed among 3 boys, there being no restriction to the number of apples given each boy may get? Anyone can have all 6 apples, anyone can have 0 apples. So a person getting apple or not is an unfixed event. What is fixed is those 6 apples. Is those 6 apples. Okay. The apple is going to get somewhere, that is for sure. So apple 1, apple 2, apple 3, apple 4, apple 5, apple 6. How many choices for the apple 1? 3. How many choices for the apple 2? Sorry, this is 1. Apple 2, 3 also, because there is no restriction. One person can have 2 apples also. For 3, third apple, there is also 3 choices, 3 choices, 3 choices, 3 choices. So 3 raised to power 6. And what was the unfixed event here? The boy getting apple or not. That was unfixed. That was chosen. Okay. So if we write and if we go by the formula, number of fixed events or elements raised to power number of chosen or non-fixed. So what was fixed? Apples. Am I doing mistake? Yes. What was fixed? was the apples. Okay. And what was not fixed was a boy getting an apple or not. So it's getting confusing here. I should better avoid writing the formula. Whenever there is any case, so always remember that the event that is fixed, that apples, this number is fixed, that every apple is going to get used somewhere. So that with every apple, it is fixed that it is going to get somewhere. Now the choice comes that to whom. So that's why we have used it as a place. This is the case, and you have to remember this. Okay? Most logical method instead of going with formula, because this term will only confuse you. Just remember one thing. Just remember one thing, that whichever element is going to fix that it is going to get completely exhausted, then it becomes a place. Ring was such, so that is why it became a place. And same case with the apples also. Is this clear, everyone? Let me give you one more example. So in this question, we have to find out in how many ways can three prizes be distributed among four boys when, first case, when a boy may get any number of prize. Any number of prizes, or in the second case, no boy should get, not a same, like no boy should get all three, all the prizes. This is a question. Now let's solve. So there are three prizes, four boys. What is fixed element here, that it is going to get completely exhausted for sure? Can anyone tell me? Prize or boy? Prize, of course, right? If there are three prize, so these prize are definitely going to get somewhere. So we'll make them as a place event. Prize 1, prize 2, prize 3. In first case, we can give any number, like the prize one can go to anyone. Like there are three choices available for the prize one. Now prize 2 can also go to any boy, even to the same boy that has already gone to. Okay, so there are still three choices. There are three choices here as well. So 3 raised to 3 becomes 27. Now, is there any doubt, anyone? Now let's discuss the second condition. In this condition, no boy should get all the prizes. Prizes are still fixed even. So the prize one can be gone to three boys. Now the choice for giving the prize to, it's still three. Okay, a boy can have two prizes, but not all three. Okay, how many choices for the prize? Three. Now it may be 3 or 2. Now it's one thing that we can not calculate by using this method, because it may happen that while giving the prize one, let's say A boy has taken it, sorry, B1 boy has taken it, This time B2 boy. So now remains three choices itself, because any boy can get two prizes, so that's not a problem. So we cannot go with the same method now. Have to go with different method, because prize 3 can be gone to three choices or two choices. It will have difference. So whenever we have any such event, which is for which finding out the number of ways is getting difficult, so we'll just find out total number of ways minus its ulta. Okay, it's opposite. No boy should, I should not have written total. No boy should get all the prizes. So a boy, its opposite is gets all the prizes. So, okay, let's solve the same question. Now, total number of ways are 27. We have already discussed about that. Minus, okay, we have done a mistake here. There were three prizes, but four boys, not three boys. Four boys were there. There were four boys. So for prize one, there are four boys to get four prize, four choices here also. 4 raised to power 3. 4 into 4, 16 into 4, 64. Okay, instead of 27, we'll write 64 total number of ways. Now, when a boy should get all the prize. So how, let's discuss about this contingency when a single boy is getting all the prizes. It may happen that boy number 1 gets it, so that's one way, or boy number 2 gets it, that's another way, or boy number 3 gets it. So these are three contingencies. So there are three ways when a single boy can win all the prizes. So basically our answer will become 64 minus 3, 61. Again, yeah, there are four boys. I'm again uh, forgetting. If boy 4 gets, there's another way. And if boy 3 gets, that's another way. So 64 minus 4 cases are there. In 4 ways, one person can get all the prices. In one way, when boy 1 get all three prices, and boy 2 and 3 and 4 gets nothing. So let me represent this correctly. That B1, B2, B3, and B4. Okay. And instead of that, let's write it like this: B2, B3, B4. So it may happen that here we are going to write number of prizes. It may happen in a case that boy 1 has won all the three prizes, okay, and they have won nothing. Or it may happen boy 1 has got nothing and boy 2 has got everything and everyone sells nothing. He has got three prizes, everyone has got nothing. Everyone has got nothing except boy 4. So there are four chances where a single boy gets all the prizes, right? So how many cases are there? 1, 2, 3, and 4. So 64 minus 4, 61 will be your answer for finding out when no boy should get all the prizes. It's like the same when we discuss sets, finding out the complement of set. We have find the total number of elements minus it with the set. So it is similarly of on the same logic. Now, if that is not clear, I can repeat. If that is clear, it's great. I'm going to ask questions if that is clear. Please read the question once again and try to understand. And if there is any doubt, please ask. Red. Any doubts, anyone?
No, sir.
Okay. So remember this thing that whenever we are not able to find out any event number of ways directly, so we'll just find out the total number of ways and subtract the opposite of the event. Okay, let's move forward and discuss one more important question. How many numbers greater than 4 0 0 0 0 can be formed by using the digits six 0 2 2 4 4 5. It is given that repetition is not allowed. Or it's almost 4 lakh. Okay, we have to make number which are greater than 4 lakh. So how many places should be there? And how many numbers do we have to make? How many digits? 1, 2, 3, 4, 5, 6. Okay, so we have to deal with only numbers which are having 6 places. Now, if any number is greater than 4 lakh, then the unit digit should be 4 or more than 4. Is everyone agree? Should be 4 and or more than 4. If like I'm saying 20, 21, 24, 19, 44, 18, 11. So the numbers who are greater than 20 have same unit digit or more than unit digit. Numbers having less than the first place, sorry, not the unit digit. The first place less than 2 are definitely smaller than 20. Okay, that's my point, that we have to make the first digit as 4 or more than 4. This has to be 4 or more than 4, which is 5 here. The only number that is there, which is greater than 4, is 5. Okay. So we'll consider two scenarios, two cases in this. When the first place is 4 or when the first place is 5. So let's discuss the first scenario, first case. So there is only one choice for the first place. How many choices for the remaining? How many choices for the remaining? We have 6 digits to use. One has already been used. So 5, 4, 3, 2, and 1. So if we multiply them, it will become 5 factorial. Now, there is a twist here. Why? In the given digits, 2 was repeating twice. 2 repeated twice. And 4 also repeated twice. And with every repetition, we divide it by its factorial with whichever number it is getting repeated. Okay, so if 2 is getting repeated twice, we are going to divide the total number of cases by 2 factorial. And there is also one more case when 4 is getting repeated twice. So we will again divide it by 2 factorial. So these are the total number of words that are going to be formed. Okay. Is that clear, everyone?
Yes, sir.
Is this right? Is 4 getting repeated twice here? Is 4 getting repeated twice here? Because we are talking about the arrangement here. It is already fixed that 4 is going to come here. So if we have already invested 4 at one place, how many 4s we are left with? Only one 4. So the 4 is not getting repeat here. So it's not twice. So that's why we'll not divide it by 2 here. Clear? Is that clear, everyone? That 4 is already used here. So how many letters do we have? Are we left with? These 5 letters. Sorry. Yes, these 5 letters, out of which, in which only 2 is getting repeated itself twice. So that's why we have divided the total number of ways by 2 factorial. Okay. 5 factorial is 120, by 2 it is 60 number of ways. If there is any doubt, I'll repeat.
No, sir.
Because 4 was already used. So how many letters are left? 1, 2, 3, 4, 5. In these 5 elements, 2 is also only getting repeated. But when we talk about the second case, where 5 is already used, how many choices are we left with now? 5. Now this time, out of 0, 2, 2, 4, 4 and 5, 5 is already used. 5 letters are remaining. So 5 factorial divided by 5 factorial. So here 5, 4, 3, 2, 1. 5 factorial divided by 2 factorial because of the repetition of 2 twice, and also 2 factorial because of the repetition of 4 twice. This time there will be 2 down here. So 120 by 4 will make it 30. Now these both are independent events. Why? Because they are making different results for the same event. So the total number of cases will be added here. We have earlier also written here 4 or 5 at the first place. 4 itself means that it's an independent event. So 60 plus 30, the answer will be 90. Please try to read this solution once again and understand why particular step is like that only. Why we have taken these two cases differently? Because of the repetition, that 4 was not getting repeated in the arrangement of the remaining 5 digits. But in the second case, where we used 5 in the first place, there 4 was getting repeated twice in the remaining 5 digits. That's why there was an additional 2 factorial division. Please read. When done, please tell.
Yes, sir.
Okay. So we have some more examples to deepen our understanding. This time we'll talk about the word Allahabad, the former word for the city Prayagraj. Okay, first question. In that question, we have to tell how many different words can be found with this letter. Total number of words. Total number of arrangements. Basically, total number of words that can be used, that can be found using the letters of this word. So how many letters are there? 4, 4 and 1. 9 letters are there. So basically, we have to, let me just directly write. We have to arrange 9 letters at 9 places. But there are some letters repeating. A letter is repeating twice, not twice, thrice, not thrice, 4 times. So divided by 4 factorial. And L is also getting repeated twice, 2 factorial. And nothing else is getting repeating itself. The total number of cases will be 9 factorial divided by 4 factorial into 2 factorial. 9 factorial can be further written as 9 into 8 into 7 into 6 into 5 into 4 factorial. 4 factorial cancels 4 factorial. 2 factorial is 2 basically. So 9 cancels, 2 cancels 8 by 4. 4. Let's find out the total. That is 36 into 5 has become 180 into 7 into 6 has become 42. So 80 into 42. And this will become, this should become 42 into 18, 0. Let's leave it. 8 2s are 16, 1 carry. 8 4s are 32 and 2. 34 and 5, 35, 3 carries. 4 into 1, 7. 756. So 756 plus 1 0. 7,560 should be our answer. And that's a correct answer. Just checked. Clear? So these are the total number of words that can be found using the word Allahabad. Now in the second part, it is asked from us that in how many of them will over, in how many of all the words that are found, them, the vowels occupy even positions. So there were 9 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Vowel positions are these. So even positions are these. The 6th position is the 8th position. How many vowels do we have? A, 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 A. So there are 4 vowels. A in the word. And 4 positions. 4 letters to be arranged on 4 positions. So that will be 4 factorial. Okay, nice. But there are also repetition. These all are same. Divided by 4 factorial. So these are the number of ways to arrange vowels. And we also have to arrange the remaining consonants. How many remaining consonants are there? 2, 3, 4, and 5 naturally. 5 factorial. But there is a repetition in letter N with letter N. So we'll divide it by 2 factorial. 4 cancels each other. 5 factorial cancels get cancelled by 2 by 5 into 4 into 3. 20 into 3 becomes 60, which is the answer. So these are the number of cases when vowels occupy even positions. Even positions. Is that clear, everyone? Clear?
Yes, sir.
Now let's talk about one more complex word, that is arrangement. Okay. Now, first we have to find out that how many total words that can be formed using the letters of this word arrangement. So let's first count how many letters are there in total. Okay, 4 and 4, 8 plus 3. So there are 11 places to be arranged. 11 letters, 11 places. But A is getting repeated once, twice. Okay. R is repeating itself for twice. N is repeating itself for twice. And G is not repeating. E is repeating itself for twice. So many repetitions. Nothing else is repeating. So these are the total number of elements. 11 into 10 into 9 into 8 into 7. 6 factorial is basically 720. Divided by 2 into 2 into 2 is basically 8 into 2. 8 cancels the 8. 2 cancels 720 by 360. We'll solve the remaining question with a lot of effort. So 11 into 9 becomes 9 into 7 becomes basically 63. Okay. 63 into 11 becomes 693. This becomes 693. Okay. Now let's multiply 693 with 360. Let's leave the 0 and there is one more 0 to count with. So two zeros, these two zeros are counted. 693 into 36, that we are counting. 6 threes are 18, 1 carry, 19 six are 54, 55, 5 carries, 6 6 are 36 plus 5, 4158, 3 3 are 9, 9 3 are 27, 2 carries, 6 3 are 18 plus 2 becomes 20, 8, 9 5 14, 1 carry, 9 4 2 with two zeros. So this has become 24 lakh 94,800. So my answer is precisely correct. I'm very happy and proud about my calculation. So that's the answer about this complex question. That was very easy question, but the calculation was tedious, strenuous. Is that clear, everyone? Any doubts?
No doubt, sir.
Let's move forward for the second part, which asks from us in how many ways of these the vowels occur together. In how many of these vowels occur together. Okay. Okay. How many vowels are there? A, and E, E. Okay. There are four vowels. Let's make a box of four places. There are four places, four things to be placed, 4 factorial, but A is getting repeated itself twice and E is also repeating itself twice. So 4 factorial is basically 24 divided by 2 into 2, 4. That is 6 number of ways to arrange inside the box. Now, How many consonants are left over? 1, 2, 3, 4, 5, 6, 7. Basically, there were 4 vowels, so of course 7 consonants are left. Now 7 consonants are left. अरे लिखा जा 7 consonants are left along with a box of vowels. Why a box of vowels? Because they has to be together. So 4 vowels and 7 consonants. Now we don't have any 4 vowels. We have a box of vowels. So how many total elements? 7 consonants and a single box. So 8 factorial. Okay, cool. But these consonants have some repetition in them. So we earlier also talked about R is repeating itself twice. So 2 factorial here. N is repeating, N is not, yes, N is repeating itself twice. So let's take a break for a second. Okay. 2 factorial for the repetition of R, 2 factorial for the repetition of N, and nothing else, nothing else. No other consonant is repeating itself. So we have to arrange 7 consonants and a box. That's why 8 factorial. 2 factorial for the repetition of consonant R, 2 factorial for the repetition of consonant N, and for the repetition of vowels, we have already considered them inside the box. Okay. And also, it will get multiplied with the arrangements of vowels inside the box. There was 6. Okay. 8 factorial into 7 into 6 factorial is 720 into 6 divided by 2 into 2 is 4. 4 divides 8 by 2. So that becomes 14. 14 into 6 becomes 14 into 6 becomes 84. Okay. Now this is 84 into 720. So we'll write 84 and 7, 2 and 0. We'll consider it later. 2 4s are 8, 8 2s are 16, 16 plus 28, 16 plus 28, that is 44, I guess. 4 carries, 8 7 ja, 4 carries, 8 7 ja 56, 56 plus 4, 6048. I guess I'm correcting. I'm doing the calculations rightly. Plus 1 0 that we had to consider. 60,480. Yes, that's precisely the answer. That is precisely the answer. Okay. If there is any doubt, please ask. Read the question again. It's important. This is called the box method. You are going to have its use in the paper. Is there any doubt?
No, sir.
Okay. There's one more question. This time we are going to discuss about the word Bharat. Okay. Before the first question asked how many total arrangements. So three, 6 letters. Is there any repetition? B is not repeating, S is not repeating, E is repeating twice, R is not repeating, T is not repeating. So 6 factorial is basically 720 by 2. How many total ways? Total number of words that can be found by arranging the letters of the word Bharat is 360. In the second question, it is asked that you have to tell the total number of words in which B and H are never together. Okay, this is what is asked from us, but that's complex, a little complex to answer. So we'll first discuss when B and H are together, and we'll subtract it from the total number of cases. So when BH and has to be together, there is a box with 2 places. There are 2 elements, so 2 factorial. Okay. How many letters are left now? 1, 2, 3, and 4. So 4 remaining letters. Let me remove my gloves. Okay, 4 remaining letters and a box is to be arranged. So how many total elements? 5 elements. Is there any repetition? No, there is no repetition other than A, which is there is a repetition in A, which is not considered inside the box. So now we have to consider it 2 factorial. So these are the total number of arrangements, and the arrangements made inside the box, there was also 2 factorial. These cancels. Total number of ways where B and H are together are 120. Okay, when B and H are never together, so we'll take total number of words minus it from the when B and H are together. That should give our answer 360 minus 120, which is 240, which is our answer. As simple as that. As simple as that. Any doubts, anyone?
No, sir.
No doubts. Okay. So there is one more question in this. How many of these words begin with B and end with T? How many of these words begin with B and end with, so how many letters were there? 6 now. So end with T. So one choice for the first, one choice for the last. And how many remaining letters are there? 4 remaining letters are there. So there will be 4 places only. 4 places, 4 words, 4 factorial. Is there any repetition? Yes, there is a repetition in A, and into 1 factorial, into 1 factorial, divided by 2 factorial, into 1, which is the number of choices available for the first and last place. So 4 factorial is 24 divided by 2. 12 is the number of ways. The answer. I believe it is clear. Yes.
Yes, sir.
Okay. So have we discussed this question? This is an important one where we have to find out its dictionary and find out and list the number of words made by this, and we have to find out the 50th word in its dictionary. Have we already discussed this or not? Any idea, anyone?
No, sir.
No idea. Actually, we have discussed this question, but if there is no idea, I should repeat. Should I? Do you guys have any idea that how this question will be solved? Guru Charan Yarini. Guru Charan is not there. Okay. Actually, we will start from all the letters of A, then we'll count the number of words that we have found, then we'll move to the next word, G, then I, then N, and then we'll count how many letters, how many words that we have skipped. If we have skipped enough number of words, we'll go on slowly and we'll find out which is the 50th word. Okay. Should I solve it once again or not? Gurucharan, have we solved this question earlier? Again, word in which we have to find its dictionary and we have to find.
Yes, sir. I remember it.
But I asked from Gurucharan, na?
Oh, okay.
Okay, anyways, surprise is gone now. Let me look if there is any important question left. We have mostly solved all the questions, but there are a few left. So this is a question using the digits. Previous year questions, okay. Using the digits 1, 2, 3, 4, 5 only once. How many numbers? How many numbers greater than 41,000 can be found? Well, this is similar to the question that we have solved earlier. So basically, if you have to find out any number greater than 41,000 with 5 places, okay, because we have only 5 digits given to us. So the first place can be 4 or greater than 4, or in the other case, it is greater than 4, which is 5 only out of the digits that are given to us. So we have one choice here, one choice here. Now with the remaining ones, we can use any digits and it will be greater than 41,000 for sure. Why? Let's say if we use the most least digit that is available to us, that is 1. Even after using this, there will be 2, 3, 4, 5 here, and that will make our number greater than 41,000 itself. So we can use here 1, 2, 3, 4, or 5. So we have, but except the digit that we have already used on the first page, that is 4. So instead of 4, there are 4 digits left. 4 choices for here, 3 choices here, 2 choices here, 1 choice here. So 4 factorial is our answer. For this number of the cases when all the numbers are starting with 4 digit, with 4 as its digit on the 10,000 place. This time there is 5. Okay. After using 5, we are left with 4 digits. So 4 choices here, 3 choices, 2 choices, 1 choices, 4 factorial here also. These are independent events because these events will be making different numbers. Okay, so 4 plus 4 factorial, make it 2 into 4 factorial. 4 factorial is 24. That is 48 should be our answer. And that is the correct answer. Is that clear, everyone? This is how easy it was. This is a previous year question. If there is no doubt, shall we move ahead? Is there any doubt? Any questions?
No, sir.
Okay. In the next, in how many ways can 5 books be selected? We are selecting books out of 10 books. If 2 specific books are not to be selected, are never selected, are never selected. So that's a simple question of combination. It is just that we have given initially 10 choices, out of which we rejected 2. So out of 8, now we have to select 5 books. So for selecting 5 out of 8, we use this formula. 8 factorial, 8 minus 5, 3 factorial into 5 factorial. 5 factorial cancels it by 8 into 7 into 6. 3 factorial is 6. 8 into 7, 56 is our answer. Is this question clear?
Yes, sir.
Okay. Now let's move ahead to solving some other important questions. In the next question, we are talking about an election. We type it. In an election, there are 8 candidates, out of which 5 candidates are to be chosen. If a vote may not, sorry, if a vote, if a voter may vote for any number of candidates but not greater than number to be chosen, then in how many ways can a voter vote? That's a question. . The question asks, there's an election. There are 8 candidates, out of which 5 candidates are to be chosen. There are 5 vacancies. Okay. If a voter may vote for any number of candidates, but not greater than the number to be chosen. So a voter can vote only for 5 candidates. He may also vote for 3 candidates. He may also vote for 1, 0, or 2, 3, 4, 5, but not greater than 5. Okay. Then in how many ways can a voter vote? Now what is unfixed here? That the number of votes he is going to cast. But it is for sure that he have to choose some. So out of 8, he may choose 1, 2, 3, 4, or 5, but not more than 5, because there are not even vacancies for more than 5. It is a given condition. So out of 8, he may choose 1, or. So when I'm writing or, so it means there's an independent event. He may select 2, or he may select 3, or he may select 4, he may select 5, but not greater than 5 because of the given condition. 8C1 is 8, 8C2 is 8 factorial upon 6 factorial into 2 factorial, 8 factorial divided by 5 factorial into 3 factorial, plus 8C4 is 8 only, 8C, oh, no, 8C4 is 8 factorial divided by 4 factorial into 4 factorial, plus 8C5 is 8 factorial divided by 5 factorial plus into 3 factorial. So this and this, and these are equal. Let's solve. 6 factorial cancels 8 factorial by 8 into 7. 2 cancels by 4. 4 into 7 becomes 28. 5 cancels 8 factorial. 5 factorial cancels 8 factorial by 8 into 7 into 6. 3 factorial is 6. 8 factorial gets cancelled by 4 factorial into by 8 into 7 into 6 into 5 into 4 factorial. That is already cancelled. 4 factorial is 24. 4 factorial can be written as 4 into 6. 6 cancels 6. 4 cancels 8 by 2. Now this is similar to this. So instead of writing this, we'll cancel this and we'll write a 2 here because it's repeating twice. Clear, everyone? Why we have neglected? Because this is coming twice, so we have just written 2 here. Now let's simplify. 8 plus 4 into 7, 28, plus 8 into 7, 56 into 2, that is 112. 2 into 7, 14 into 5, 70. 8 into 8 plus 20, 8 plus 28 plus 70 become 98. 98 plus 8 becomes 106 plus 112. 12, 6, 18, 100, 200. So 218 is a correct answer. A voter may vote in 218 different ways. How interesting this election is. ठीक है we so the voter can select 1 candidate or 2 or 3 or 4 or 5. That is what needed to be understand from the complex language of the given question, and UPSC plays with the language of question. So you may have high comprehensive skills with the mathematics question. Should have. Okay, now please reread the question and try to understand how it is solved. Just first 2 lines calculation is no needed to be read again. Please prompt when done. Guru Charan, is the question clear? Guru Charan. A chat. Yes, sir. Then please, can you unmute yourself and explain what the question is asking? Okay. God bless your network, bro. What about Yarini? Can you explain the question? At least try.
Sir, actually, there's an election. So there are 8 candidates. From that, the people have to choose 5 candidates. But the thing here is, they can like vote to any of the candidates out there, but not above 5, it seems. So, like, they are asking how many ways a voter can vote. So, which is we have to find the number of combinations here. Is it correct?
Yes, it's precisely that. Very good. Can you now explain how we have solved it? Try. Can you explain what is NCR? Combination NCR. What is N? What is R? The number of selections that can be made when we select R things out of N is NCR. Now relate the same formula with the solution written here. Try, no problem. Just at least try. So NCR means selecting R things out of N. So we may select one candidate out of 8, or 2 candidate out of 8, or 3 candidate out of 8, or 4 candidates out of 8, or 5 candidates out of 8. That's what its meaning is. Clear?
Yes, sir.
Yeah. Okay, so now let's move ahead with the next question. Next question is a question which like which was very hard for me to understand when I was a student. So I'll try to make it simple for you. So there are 6 letters that you have written for someone's facial, and there are 3 post boxes. Okay. So the number of ways in which these letters can be posted. In which these letters be posted is that what we have to find out the number of ways basically. Okay, so now what is fixed here, that what is definitely going to get consumed, is it the post box or the letter? Can we leave any of the letter? Can we leave any post box for our objective? See, here post box is not important for us. What is important is our love letter that we have written. So that letter has to be posted for sure. Using which post box, that is our choice. Right? So letter is for sure that it is going. So letter, we will make our 6 letters as our 6 places. L1, L2, L3, L4, L5, L6. So L1 letter can be posted via any box. So 3 choices are there. Same 3 choices for the letter 2. Same 3 choices for third. Same 3 choices for all the letters. They are dependent events. So we'll multiply. Now 3 into 3 into 3. So basically 3 is getting multiplied 6 times. This is our answer basically. You may get confused in exam. Should I write 3 post boxes like this and will post letters? No. Why no? Because post boxes are not fixed. They are not fixed event that you have to choose. Okay? Letters are fixed. Letters are definitely going to get exhaust. All the letters are going to get used. Okay, choices comes when we have to select the particular post box. Is that clear?
Yes, sir.
Okay. I hope these 6 letters are going to the same person. There are 4 candidates for the post of a lecturate in maths, and one is to be selected by votes of 5 men. Let me write it. There are 4 candidates for the post of a lecturate in maths, and one is to be selected by votes of 5 men. What is the number of ways in which the votes can be given? There are some options given. We will not consider them. So there are 4 candidates for the post of a lecturate in maths, and one is to be selected by votes of 5 men. Now, votes of 5 men, this is an event, and there are 4 choices available. This is another event. So what is fixed here? Are these candidates fixed or the vote of men is fixed? Please respond. By having fixed, I mean that which particular event is going to exhaust itself completely. That it is for sure that is going to happen. Whether these five men are definitely going to vote, or these four candidates are going to definitely going to make themselves to the lecturate maths position. It is indeed that only one candidate is going to get select. But these five men of board will definitely vote. It is a definite thing. So let's say man one votes. So let's make the votes of these persons as places. Man two, man three, man fourth, fifth man. How many choices do they have? They have four candidates, four umidwar to select from. So four choices here, four choices with M2 also, four choices, four choices. So four getting multiplied five times. This is the answer. And what most of the students make mistake here is writing it otherwise. Writing candidate one, candidate two at the places, and they end up giving wrong answers. Okay, so you have to consider a thing, note it down that fixed event is going to become or occupy places or be places, is going to become places. That's a very grammatically incorrect sounding statement, but you may understand what I mean by fixed event. The event that is definitely going to happen, that is for sure happening completely. That is a fixed event. Places means this. In this case, the vote of first man, the vote of second man, like this. Is that clear? And in this concept, is everything clear in this concept? Any doubts?
No, sir.
4 raised to power 5 can be written as 2 raised to power 10. How can anyone explain? Can anyone explain? No? Because 4 can be written as 2 square. So 2 raised to power 2 raised to power 5. 2 and 5 will get multiplied. Right? And this is the property a raised to power m raised to power n is a raised to power m into n. Simple. Let's go to next question. In this question, clear everyone? Is this question clear? No? Or yes? Please respond.
Clear, sir.
Clear. What has happened? If 11 members of a committee sit at a round table so that the president and secretary always sit together. I hope I'm pronouncing it correctly. Then the number of arrangements are this is a round table. Nice. So let's make a round table then. Round table. How many people are there? 11 members are there. Okay. And in those 11 members, there's a president and a secretary. So president want to sit with the secretary. So let's make a box once again. In that box, let's make two places on which president or secretary can sit. So I'm saying SIT. So 2 factorial is the number of ways to arrange them inside the box. So two members are there, and if we have if we have already made president secretary sit in a box, then how many are left? 11 minus 2, 9. So 9 members and the box. Okay. So in total, 10 people are needed. In total, 10 elements are to be arranged in circular manner. And we remember the formula of n elements getting arranged in a circular manner is n minus 1 factorial. So 10 minus 1 will become 9 factorial. Okay. So 9 factorial is the way to make 10 elements arranged on the circle. But there was also an internal arrangement inside the box. So that is also dependent. So this is our answer. Clear. And this is only the answer. The options will have option number A is 2 10 factorial, 2 into 10 factorial. Option number B is 10 factorial. Option number C is 2 into 9 factorial, which is our correct answer. Option number D is none of the above. Clear?
Yes, sir.
Yes. So now there is a question for you to do in the homework. Okay, and please do it. Let me. Okay. So in an election, the number of candidates is one greater than the persons to be elected. If a voter can vote in 25 ways, 245 ways, sorry, then the number of candidates are, that is, you have to find out. Options are 7, 10, 8, or 5. These are your options. So your homework question. Is there any doubt?
No, sir.
Apologies. My English is very London Oxford English, high level English.